Hi guys, good evening. I'm just starting to introduce myself because I want to introduce the guests themselves a little bit. So I'm Jasper, I'm a VC, Holtzbrinck Ventures. We're a €1 billion fund here in Berlin, investing in all kinds of businesses. The most known is Zalando, pretty big company here in Berlin. But what is more important is our guest here tonight. So I would like to welcome Darja from Bunch.ai. You're supposed to clap. Thank you. Erik from Solvemate. And Ilya from I2X. And I should maybe mention we have two CEO and founders there, to the left side, and Ilya is CTO. And as you just heard, it's about humanizing AI. And that's a pretty challenging topic for us guys, because I imagine all of you three are trying to earn some money with artificial intelligence, and I'm trying to invest money in artificial intelligence. So just to set the stage right here. So I would like to start to let our guests introduce themselves very, very briefly. Who you are, what's maybe special about you, then what's your company doing in a short sentence, what's your educational background, and how did you learn to apply AI? Maybe we start with the lady, if it's okay.
All right. Thank you so much. Super happy to be here. Hi, everyone. So I'm going to start with a background. So I'm a psychologist by training. When I graduated, I didn't know I'm going to have job opportunities. That was before behavioral data science age. And so I did consulting, and then I did PhD studies. So went into like the data science direction by chance, and ended up building a recommendation machine for travelers first. Was my first startup, and then kind of like accidentally ended up doing what I'm doing now. And what we're doing is basically utilizing AI and psychology to help small to medium-sized tech businesses to hire faster and better candidates. Of course, it has to do with sourcing and also screening, and so we utilize the ability not only to match candidates based on skills, hard skills and experience, but also soft skills, mindset, and cultural, psychological dimensions. And one last word, how did I get to apply AI? I think that's actually probably the most interesting point. When we started out the venture, we were actually helping investors to understand the founder dynamics better. And we got quite a bit of traction with it, so I couldn't execute it with two freelancer psychologists anymore. And so we stumbled upon this startup that was called Affectiva AI. Part of our assessment was to read mimics from founders' faces to basically classify them in specific trust categories. And so we utilized this API with like a freelance developer that helped us. And so this was the first time that I came across it.
And then we can still use that?
Let's talk about it after.
Yeah. Erik?
Hi, my name is Erik Pfannmöller. I'm the CEO and founder of Solvemate. What's special about me, I have been a professional sportsman before being a founder. If you know whitewater canoe slalom, I've been a world champion in this before I started my business career. So I'm a business person. I went to a business school, I founded my first company, built it up to 70 employees and 20 million revenue, an e-commerce company. And then, what was my way into AI? I said, I'm a very technical math-driven person, like I math and statistics, and I sat down in a room for a year, which is also special about me, and I just wanted to understand the data value chain. Which data can you crunch by which algorithm to produce which model to make real-time predictions, because that's what machine learning / AI is doing. And after a year of research in a small room with only me, a lot of YouTube videos, a lot of meetups, and a lot of lunch appointments, and a lot of scientific papers, I stumbled upon a problem, and I knew that problem from my former company, this customer support. It's thousands of tickets, highly repetitive, and we had a call center of 15 support agents. And then my father called me, said, son, I can't send emails anymore. I was a support agent, I solved it on the phone, and that was the idea that we're gonna build chatbots or support bots that automate customer support so that people can help themselves. That's our business model, and every month hundreds of thousands of end users are doing so.
Cool, thank you. Ilya, what about you?
Thank you. My name is Ilya Edrenkin. I'm currently CTO of I2X, a Berlin-based speech technology company. What we do, we install speech recognition software in call centers and other sales venues. And we help the sales agents to sell better and more by recognizing their speech and providing real-time feedback. Regarding my background, a long time ago I did a PhD in computational neuroscience, so I'm coming from both biology and mathematics. Later I worked for Yandex, which is kind of Russian Google. First for speech technology. Yes, it's sort of the largest search engine in Russia. First on speech technology, speech recognition, text-to-speech, voice biometrics. My team has built the whole stack. And later for research and development of self-driving cars. For the last year, I'm with I2X here in Berlin.
Cool, thanks very much. So we don't want to, because I guess all of you know very, very deeply how your algorithms work, what you're applying there. But I guess for the audience, and please also for myself, let's try to stay on a comprehensive level for normal people. But let's maybe start getting into the topic of humanizing AI and what's possible by just explaining each one of you what type of machine learning, I mean, I prefer that word, you're applying in your company and for what purpose. Why are you using it? I mean, you could probably use other things. Who would like to start?
So we are doing conditional probabilities and naive Bayes in combination with some kind of decision tree logic and parts of reinforcement learning, just for the staying on top of the level. Why are we doing this? Kind of these support bots are learning the path that users go, and then we have a front-end algorithm that helps the user to guide them to the right solution, to find the 1 out of the 100 standard cases in support. And we got a back-end algorithm that is basically helping the support agent training the system so that the customer can help themselves. So that's two part of our business, two completely different algorithms.
Cool, okay.
And I go next. So we utilize two things. So we work with psychological model on the one hand. So we partnered with Stanford that already validated specific dimensions that play a role when you look into how teams work together. So we didn't start from like zero kind of like bottom-up approach where we did everything from scratch. We used an existing model. And so we started using classifiers at first to train an NLP algorithm that basically matches these psychological 6 dimensions that play a role when people work together, like how detailed you are in your approach, how collaborative you are, how customer-oriented you behave, and so on. So behavioral dimensions. And we started building, we started with a parser actually, and now went into full-blown training NLP models to literally translate text written by a human and to a psychological profile of these 6 dimensions. And the second thing that we use is a simple classifier model that, and feature extraction model that basically helps understand which hard skills on like a LinkedIn profile or in a CV, for instance, are related with which of these behavioral dimensions.
A simple classifier model? Or
I mean, I'm trying to, admittedly, this is much better explained by our CTO and our data scientists. So I don't want to go into details because I'm...
No, just that you said simple classifier, and I
mean,
think there
it's
are
like a
simple
categorization model, so it's a regression in the end. Nothing super fancy. I would say like the standard stack of machine learning for the hard skills, and then a bit more sophisticated NLP, judging by the time we spend on each to get to like minimum algorithmical value in product. I think the NLP is more, yeah.
It's probably super simple from a Stanford point of view. Ilya, what are you guys doing?
The core machine learning technology at I2X is speech recognition, and basically there are 2 components, language modeling and acoustic modeling. Language modeling is done both using well-known n-grams, recurrent neural networks, and other well-known stuff. Also, because language model defines a search space, we have to use probabilistic graphical models, something simple like weighted thin state reducers, to define what's the possible set of phrases in the language to be recognized. On the acoustic modeling side, it's typically deep neural networks, varieties of them, which basically work as a mission function for HMM.
You lost me already, but the good thing is we work pretty closely together as we're an investor in I2X, but I always lose here.
It's pretty simple stuff, but...
yeah, I think 90% of the people understood it, but I wasn't part of it.
It's just tersely communicated in 10 sentences.
Cool. So talking about the human factor in there, I mean, you're listening to what humans are saying, you're looking at human psychological patterns that you recognize, you look answers, questions, answers, so there's definitely some human interaction. Let's split it up. How important is the human factor for you at this stage? And what happens if you don't recognize that human factor? Why is it a critical factor in your business?
All right, maybe I start because the human factor is at the core of our AI-first business. I think, but I don't want to talk about the psychology part of it too much because that's like product, and if you're interested, you can check it out and dig deeper. I think Bunch.ai, exactly. I think the issue that I want to bring up is actually the issue that we underestimated. So we knew we're doing psychology, and we knew we need to focus on like good research, and we also like I used parts of my PhD research to kind of like build it on top. So there is I can relate to this kind of like sitting in the room and reading tons of papers. So like we knew we need to do that, so we did that, great. But what we underestimated is that with almost every machine learning driven product, you're building for human users, and therefore you need to design for trust, which is a huge challenge for machine learning products because, as we know, there's a lot of black boxing, and not even the people that create it can always answer questions around why the result is the way it is in a very simplistic way, and then imagine this in a digital like user interface that we all know is very limited in real estate, and like you can't put huge scientific papers and let them read it. And I think the design of machine learning, like core problem products, is a much bigger challenge in my eyes. It has much more to do with the human AI link than the actual algorithms that we train to produce.
And concretely with your product, what happens if you fail on that human factor?
Yeah, so basically you don't get adoption. Like you can deliver to very early innovators that are happy to look at your like fancy graphs and help you to understand what else you need to show and tell them in order to actually get to the point. And I'm really happy to say that actually Solvemate's one of our early customers. And
great product, by the way, Bunch.ai.
And Erik's co-founder has been amazing, the CTO, and we had a lot of very technical people at first actually using it because it also kind of like covers this psychology for non-psychology people are, you know, like we tell you, we help you with like an interactive data-driven way actually discover things about the other side, the other human side. And
maybe I should answer your question about humanizing your product.
Yeah.
We've been on a company offsite using their product, and it's about assessing teammates and their psychological traits. And that was really interesting because you said something about black box, and you need to solve the black box thing. You know, you're answering a few questions, you figure out what your colleague is, and you get insights, and it's about interacting with an algorithm that gives you an information. And everyone knows back then in the days where they have a navigation system and you didn't trust the system because navigations are just bad, like 5-10 years ago, and you think you were smarter. That also happens today, not anymore with Google Maps, because it's just such a great algorithm, it's just working better. And that factor of humanizing AI at Solvemate, we have the same problem. We don't do natural language chatbots. While automating support, we do structured answers. And I strongly believe, like multiple choice, I strongly believe you should never pretend to be a human if you are a virtual agent, like a chatbot. That's the first thing. So don't pretend to do so. And if you don't pretend to do so, do you need to humanize? I think in automating customer support, you don't. It's just about, like, you don't want to get on the phone, you want to have your request solved instantaneous. So to the end consumer, it's just about getting the value. And a bit of black box is okay, but it should be understandable. If our algorithm proposes stupid questions to the end consumer, they drop off. So it's about being logical. And that is important. That is like humanizing, going a good path, like giving good recommendations for psychological traits, giving good recommendations for what is my problem. Otherwise, people stop working with machines.
There's one more point that actually relates to what you said, and I think it's really interesting to differentiate. So it took me a while. It was like I think a revelation like a year ago or so, but we have different categories of AI in products, right? Like there is simple SaaS tools, like when we had the cloud, okay, great, now we can go online and actually get problem solved online. And then we had SaaS tools infused with AI, like every big company that actually had the ability to afford machine learning started, or almost every, started investing into that. And then they started to improve parts of the product utilizing new machine learning algorithms. And then there is like this new generation, which has AI at the core. The value proposition is AI first companies. And I think what's different about these products and companies is that if you remember when you interact with analytical products, so you have like dashboards and settings and segments, and it's like every CRM looks like this, you need to pick different settings from like a dashboard or an interface that was designed for everyone. And that's what makes it cluttered, and that's what makes it complicated most of the time, and so on. And so what AI first allows you to do is to think in design phase, actually, the different journeys through the product. And if you notice, I don't know, like when you interact with AI products, they always have this typical like 5 questions in the beginning, right? Like before we start, let me like tell me something about what your problem is and like who you are and so on. There is like a very short sequence of questions. And basically what this does is like predetermining for you which route are you going to take through the product, and then which algorithms are going to be used and which parameters are going to be set. And I think this is very specific and special, and I think that's what also makes it a bit easier to interact with. While I agree it's not necessarily human, but it actually improves the user experience quite a bit, and it's an aspect that some people that actually don't even think about, but it's common to most AI-first products.
Cool. Ilya, following what we heard from Edward Snowden, how do your customers feel when they know somebody's listening and analyzing them?
They sign a paper. They agree with that.
So is that an important factor for you guys? Or how do
absolutely.
You do that? Yeah.
So with the call center agents, the very fact that someone pays attention to their work is a strong factor. And it can be both a motivator or a demotivator. So from a human perspective, it's important to frame it in a way which is not scary. So to the possible extent, so always will be people who are frightened by the fact of observation, but we can try to make it as friendly as possible. So what we do gamification with the call center agents, and they turn out they just love it. You can just do simple games like sell more, and call centers do it a lot, but it's not always in control of the agent. But you can always give them targets which are easily achievable. Maybe you cannot sell, but you can at least mention the best and the most sellable products right now. And we can record it and assign some points for that. And you get the first place in local competition, maybe some monetary award for diligently following the sales script. And it turns out it helps both the call center, because all the metrics look much better now, and also the call center agents feel better because they can do something and get rewarded immediately.
So coming to the general question, it sounds a little bit like human AI is an AI that helps the people using it, and they really feel that there is value, but you also have to sell it to some extent. Is that because, getting a little bit, let's say, more controversial here, at the end of the day, you are just killing jobs with your companies?
I would say there's 2 dimensions to that. First of all, it's about the usage of the product. Let's assume you use Google Maps or a chatbot or a very cool tool that listens to your calls as a support agent. If you get weird recommendations, you're going to think, I'm smarter than the machine. That's about the user and the result, the humanizing the result. Although the machine usually is smarter. But on the other side, like this... the comment was not always, yes, that's true, but on a probabilistic level, the good machines should be better. And I strongly trust Google Maps more than myself, my navigational skills. But this is only the one dimension of humanizing. The second is about selling it to humans. And when you sell a software in a B2B or B2C space, you need to convince people and you need to explain how it works. And it's not about input, black box, output. People need to understand. People ask us, how do your algorithms work? And we need to explain how it works. They don't need to understand deep recurrent neural networks or Bayes theorem or other algorithms, but they need to understand how it works, because then nobody is going to buy a black box. And humanizing the selling process is a tough thing for AI-first startups.
And usually works good with examples, I believe, that are much more simplistic than what it actually really is. So it's always a bit of a thin line, I feel, when you have like principled people on board, and most of people that go into data science are actually quite principled. It's always a trade-off from a marketing perspective to go to your data scientist and your machine learning engineer. It's like, okay, we're going to put on this piece of material that it works like this. And then, no, it does not work like this. Yes, but this is how people understand it when it works. So it's always a trade-off between how detailed you go and how graspable it really is. And in my eyes, if a person doesn't understand the details, it's not worth saying. So until
and you need to do this in PowerPoint slides usually, in PDF things, without like maybe having GIFs, which is really powerful because GIFs work also in the browser with an internet connection. But explaining a machine learning algorithm with examples in slides in a sales meeting, remote, that's tough. But it's humanizing AI.
Back to a question. What's really disappointing with machine learning as of now, and so really good for the job market, is that machine learning is now able to automate only the easiest and most menial tasks. That means that yes, we push people out of jobs, out of the menial jobs, which can be automated with the current state of the art of machine learning. Unfortunately, maybe fortunately, machine learning is not able to automate human fully as of now. Therefore, humans have more time for more interesting jobs.
Which is maybe to give a very specific example, what we experienced is when we try to, we usually sell to non-HR people, but of course then the user oftentimes is the source and the recruiter that works on the team. And so there's always a conversation of like, okay, how much and how does this, like, is this threatful for me? And very often, very quickly, it becomes very obvious that the task we automate is the most tedious one that eats the most time, namely going on LinkedIn and then like scraping like profiles, putting them in a list or ATS to actually reach out to people later, so like passive candidates. And that's a task that just everyone simply hates and like pushes up to the last minute and like doesn't enjoy. And what they much rather do is building relationship with the relevant people. So basically we enable them to actually have more time to build those relationships by focusing on like most relevant candidates for them. And yeah, once you actually frame it that way, I think there was like simply no person that actually said, oh yeah, that doesn't make sense. I want to like screen 150 profiles per hour on LinkedIn. It's a very enjoyable task.
Just to add to this, there's always this short-term dimension of what is the person doing each day. Like on our side, customer support agents doing 10 times the same thing. A person told me personally, I'm relieved I'm not doing the repetitive stuff. Now I can consult my clients that are calling me. That is the short-term on a personal level interpretation. And on a bigger scale, on a meta level, it's just a megatrend that is going to shift the way how we interact. So when the steam engine was invented, there was no people riding horses anymore. And when the cars came out, nobody was using steam engines. And machine learning is just something that is a dramatic shift in how we interact. And yes, I would say in 5 years from now, we have a third less support agents. That is just what's going to happen. And the other third, they are going to more humanized, more specialized, more valuable jobs, basically earning more money or having a better life for them and not doing repetitive, stupid tasks.
So another controversial thing about AI could be that there is certain bias involved. I mean, from a non-scientific perspective, let's say it very simple, you take a data sample, and in that data sample there are only certain people, certain ethnical people, for example. And then obviously for other ethnics it doesn't work. Another thing could be ethics, so rules that you learn from your parents. Could be a rule engine, obviously, but people are able to adopt human beings. And when I show my son a picture of a zebra, he can identify the next zebra instantly, but a machine learning algorithm needs a couple of zebras. So is that bias a problem to create something more human, something that is adaptable, something that thinks really and says, yes, that's what I learned, but it doesn't really make sense, looking also at self-driving autonomous cars? Or do you think it doesn't matter for especially your businesses where you're applying it?
That is a very tough question. First of all, I think bias from humans are something like heuristics. So people tend to believe people being out there in the dark in a park are more criminalistic than being not in the dark on Sunday morning somewhere else. So that's heuristics that have been shaped over thousands of years, which is something good that people think. But it's only a problem if it's a false positive or a false negative. So if the heuristic is wrong, that bias. A machine learning model always needs to deal with wrong answers, either wrong data points or wrong training. So every algorithm needs to deal with wrong inputs, and humans are not perfect. Humans make mistakes. If you got bad training data, bad output. Clear problem, every algorithm needs to deal with it.
And since we all know that biases are very evident in selecting people you work with, as we, I think, read in so many papers and so many news articles, and or at least that's a feeling I have. Do you guys agree, like, that bias is a... Okay, good. Yeah, just nodding people. So, okay, bias is a problem in hiring. We all are aware. So, like, literally, I don't think there is a good solution. However, I'm still building products that use machine learning that help select people. So, I think there is things to do to mitigate, and the things we chose are, we choose to work with sciences that help us to reverse biases that we can spot. So we identify thresholds that we test the output that we produce on, kind of like so you remember the Amazon article around like, oh yeah, we trained this machine and then it turned out that it actually biases against women and so on. So you can define thresholds, like what do you want it to do in the end, and if the algorithm doesn't produce that outcome, it's simply not good enough to be released, and you need to continue adjusting the approaches you take to actually produce the outcome that you want.
But now the question is, if you get a bias that you see there is there, but the algorithm is against the human bias, but having a better prediction than the humans, what do? Do you prefer the bias or the better result?
Well, I think in hiring it's very ethical. You have a very political
That's why
agenda.
I'm asking the question.
Yeah, exactly. And I think it's a very easy answer. So, like, what's the point of training an algorithm that predicts better, that then biases more towards the problems that we already have? I don't think in my business we have that choice anymore, which might be different in other businesses where it's not such like a politically loaded topic. So in our case, it's a very clear, we have a quality measure and we have like a fairness measure. And if the fairness measure is not there, the quality measure doesn't matter. If the quality measure isn't there, then it also doesn't matter because it doesn't produce enough value. So it's just harder and longer for us to do the same thing as like in other areas. And in order to stay objective, which was something that we just actually introduced not so long ago, was to work with neutral, like, third parties to have, as you know, there's data protection officers, right? For machine learning startups in the US, I learned when I went last time, you actually have the same kind of service where you can pick experts in your specific area that are supposedly neutral. I mean, they're not invested in your business and they're not related to the strategic agendas and stuff like that. So it's like a data fairness officer that is also very much into the topic, and that you then can basically contract to help you stay on top of like your bias situations. And so we're currently speaking to someone in Boston to actually make that agreement, and I think that's a really good way. And the third thing is, I think you need to think about the misuse and abuse of the recommendations that you're producing beforehand. So even though you won't predict all of them, but there is a lot of like very obvious ones sometimes that are still not taken care of. I think that's like just also a design parameter that you need to consider. So it's just like harder to produce a good machine learning result that is then also fair, because two parameters.
Yeah, I have to ask you a question in regards to autonomous driving, because I think that's even tougher than what Darja is doing, and you might have some insights there, as I know. If you can't answer, please let us know. But level 5 autonomous driving, if I learn it correctly, the car is taking the decision. Were you guys discussing that, how to do it, how to make it a human decision?
Okay, I can answer in general without referring to any particular company or implementation. The biggest problem in self-driving is estimating uncertainty. So how do you understand that the model doesn't understand what it sees? There is a huge body of research on that, and it's a solvable problem as of now, but it's still an open research problem. So how do we teach the model to understand that the model does not understand what it sees?
So you're not taking your hands off the wheel?
It's not level 5, obviously, but in general, yes, how to make extra braking or how to signal their alarm bell and so forth.
Okay, cool. So for the last minutes, before you probably have some questions, let's go a bit crazy and look into the future. What do you see? I mean, you're reading research papers extensively, obviously.
Not anymore so
Not
much,
anymore,
but
at
in
least
the
a little
beginning,
bit.
yes.
What is currently coming at us that would make machine learning, artificial intelligence whatsoever more human-like, what we just discussed here on the panel? Do you see anything happening that would improve that factor?
So I think a very interesting company to watch, if you're not familiar with it yet, is Affectiva AI. I think they've come a very long way, and they simply started with recognition of emotional modules in the face, or the way we express emotions is for using specific muscles, and so it's actually quite old research, like from the 60s and 70s, and they just applied that and enabled to do this at scale automatically. But the vision of the company, and I really like their CEO, she's also coming out of research, and where they're going is basically building a stack that then can be used by other AI applications to actually recognize human emotions, which obviously improves a lot of things from relationship building and like interaction context, but maybe also even in like, I'm going on a limb because I have no idea about autonomous driving, but I can imagine that if you actually have that as an additional data parameter, seeing emotional reactions in people around in the surroundings, definitely very, very helpful. And so I think it's a good company to watch. They also do a lot of like really good research and publications on the topic.
Cool.
I think humanizing in the future is more about getting into my private, personal human life. So when I see Apple suggesting me a slideshow of my photos that just are amazing and they're done by algorithms, that's crazy. If I see Google suggesting me I should follow up to an email I sent 3 days ago because I said like, hey, what's about? Like it automatically says, do you want to follow up to that email automatically? And something like Siri last time telling me, do you want to call back this person who called you yesterday? And it's doing this automatically. And if you understand the tech behind, it's kind of augmenting me already. I'm kind of feeling like a cyborg if these machine learning algorithms are humanizing doing this. Like that is, I think, the most important one, just to name a few examples. And it's going to be much more in the next years.
What I believe are really interesting advances are the ongoing convergence of neuroscience and machine learning. For example, DeepMind's work on grid cells and hippocampal circuits. So unfortunately, it will not solve the bias problem, and it will be follow-up to the previous question. I believe that bias is inherent to statistical learning itself, because we humans have a lot of biases. And unfortunately, these biases often help. They are often correct. They save computation, and they help us make quick decisions. Quite often, these decisions are completely wrong. But that's how evolution hardwired our brains to optimize for computation. It also can serve, more technically, it can serve as a regularizer, as a comfort eraser. If you cannot model the whole situation, you just make some ballpark estimates and you end up with biases. You can end up with biases with machine learning model as well with human brain, doing inferences on a limited amount of data. And the amount of data in real life is always very limited, and you have to make decisions quickly if you want to survive. Thankfully, there is an alternative to statistical machine learning. That's model-based learning or symbolic AI, not machine learning, not statistics. If we can truly understand how a situation works, if we can build a correct model of the environment, then we don't even need learning. We can just, or learning in machine learning sense. We can just say what is the truth. However, computationally, it's almost always infeasible. So I believe that these two things, the first one is convergence of neuroscience and machine learning with new ideas coming from neuroscience, and also convergence of symbolic AI and statistical machine learning will help both to humanize it and to reduce biases a lot.
Cool, thank you very much. Then I would say let's hand over to the audience and your questions. And I have no idea how we do it, but I have a microphone, so I can walk around. Oh, hello. We start here. Yes.
Hi, thanks for the discussion. My question is to Ilya, who, because it touches on what you last said. There's this problem on one hand of biases, and the definition of bias, as it can both be something within society, and then you have like a model bias. But what I want to touch on, and I'll give a short example to demonstrate what I mean. There is, for example, this system in the US where they use algorithms to decide where to allocate their police officers. And just by doing that, they distort the data they base their model on. Because if you send more police officers to a certain area, obviously you'll find more crime just by there being more people to detect crime. And so you get into that cycle. So based on your last statement, how do you feel about that? Or?
Well, that's unfortunate. On a more serious note, to me it sounds like a policy issue, and whenever we apply any technology, machine learning included of course, we'll have to account for the fact that the implementation of technology or any action will shift the observations. I strongly believe there is no silver bullet, and in this case, we only have to be aware of that, and as far as possible, be able to estimate the amount of observational bias that we're introducing and correct for that. Apparently, it does not sound too actionable, but we can at least try.
But that is a problem for every company. For I2X, if they analyze the speech of sales agents and give them recommendations, they changed how the agent speaks. If we suggest certain solutions to customers for service, we change how people, like what they ask. We change the flow. Like we have the same problem, you have the same problem, the police officers have the problem. And I assume Bunch.ai has the same problem.
We also have quality checks, and then we basically like check how many, first of all, how satisfied is the person that then is selecting people, and then we're trying to check much further, like do they actually get offers, do they get accepted, and do they then stay? But even then, if you kind of like got this person present, you didn't see all the other ones, like how do you know whether they're actually the right ones? And yeah, it's the same issue.
Cool, next one. Quick, please.
Well, so I'm concerned that the term humanizing is deeply loaded in the same way AI is deeply loaded. Just hearing in the course of this conversation, there's 7 versions the way the term humanizing has worked. I won't go through more, but basically it's making AI more personable, making processes more trusted. There's making AIs conform with our ethical judgments, political intuitions around biases. There's making AIs interpret human factors like emotions. There's making AI seem more human. There's making AIs which replicate human-level intelligence. And there's build AIs towards, which we didn't talk about today, which is building AIs to protect a human future. So I think it's really, this isn't a question, this is just, I think we need to be careful with terms like humanizing, because actually they're really loaded and they mean many things.
Thank you. Question?
Thank you. Erik, I have a question, because you said you can't sell a black box, and everything I buy that is electronic is a black box for me, and I've bought it and people sold it to me. And so I'm just wondering, how long do you think is it going to take until you can just sell AI products to people, like machine learning based products to people, without them asking how it works? Because I never asked anybody at Apple how my iPhone works.
I strongly agree to what you say. If all people would be as technically loving as we do, that's great. Everything that people don't understand, that they don't see used on a large scale, they want to understand. Nobody asks how the Google search algorithm works, because it just works. Nobody asks how the autofocus on an iPhone works, because it just works. If you see the results on a large scale, you're convinced that it's just great. But if you're selling something new, something radical, something innovative, people want to understand how are you doing this, because humans are curious. I would say 2 to 3 more years until buyers and call centers have understood that chatbots are working, and the only thing, I've been written an article about this. like that buyers in 1 to 2 years will only look on the return on investment, how much tickets are deflected, and they look on the percentage of self-service rate, and not how does it work, I don't understand it. It's a question of adoption, and I think in chatbots, it's 1 to 2 years until the buyers have understood.
Good, let's continue. Don't be scared.
Hi, I have a question for the case of Solvemate. You have already explained what you have done. I wonder what it's to do. What's the next step for Solvemate?
That is a very specific question, which I'm going to answer along on a beer after this talk. In short, we've developed a product that actually works. We deflect more than 80% of incoming tickets, so it's about growth. It's about building a world-changing product and not only helping a few 100,000 people every month.
Okay, so you're invited for a beer. Oh.
Hi, I have a question for Darja. I'm Shobha, co-founder of a startup called Hard Skills. I was wondering two things. One is, how are you actually verifying that your interpretation?
So do you mean like whether the recommendations of candidates are valuable or like more helpful?
No, even deeper behind that, right? Whether the interpretation of your mechanism is good, because you're trying to gauge team dynamics, right? And you're making conclusions.
No, so I need to clarify a little bit, because I think the confusing part was that so we went through different stages, and we now just recently were able to actually train a model to recognize like most relevant candidates for specific companies and specific industries and specific stage of companies. When we were building up the data set to be able to train that model, we actually went much more into, like, we were selling an assessment-based product. This is also how Solvemate started with us, I believe. So the way it worked before was you go into a company and then you measure the team dynamics in an existing company by utilizing validated psychological instruments that were already around for like a long time and have been validated with different data sets. And therefore we teamed up with a group of researchers, and then basically what we did is basically to use public data to predict the same profiles that people would normally fill out. So it's a very interesting question, because in the end it all boils down to how much value does this person add when it goes into this job, into this company, into this team. And we're tracking different KPIs with our existing customers. So the first most easy one, which is not the very like correct one, but it's good like short-term first step, which is asking the people that get to work with the candidate that starts, as well as the people involved in the hiring process, to rate the quality of candidates on a weekly basis. And the second step is we identify that this is the KPI that is the easiest for companies to track, and also has an indication on the quality of the new ad. We are tracking retention with some of our clients. So we see how long does the person then stay. And since it's relatively new, like I wish I would have better answers. We have a really good one reference client that we're working with since a year. And they basically decreased the churn of candidates that was quite high, around 40% when they started to work with us while in a high growth phase, to 10%. So instead of 60%, 90% are staying with them beyond the probation period. So we try to use KPIs that are like proxies for quality. Obviously, it's not the holy grail, but that's what is feasible right now.
Cool, thank you very much. Looking at Mercedes, do we still have time? One last question. Okay, now, come on. One question, no more questions? There is one, very good.
So I'm working for a startup developing quality standards for AI. And you were talking a lot about compatibility of AI in general, but I think you also talked about bias, and so my concern is also the robustness, basically, of AI components. You were talking about autonomous cars, for example, and recent studies have shown that neural networks are not as robust as we want them to be. This means that, for example, a car that has to recognize people on the road, or of the cameras, the pictures that they get, they do not recognize them if you just change the input a little bit. The human would recognize it, but the car would not. So Erik, you talked about that AI should be as good as or even better than the human, but apparently this is not always the case. So what do you think are such so-called adversarial examples? Do they play a role in your work?
An adversary example is always like the algorithms being wrong. So if you work for standards, like every AI company should use the right metrics like precision and recall and the confusion metrics, false positives. What you described is a person not being recognized is like it's something false from the algorithm. We deal with that. If we recognize the wrong intent for a customer and support, we are wrong. That's obviously bad. If we would be a medical diagnosing company, we would say a person has cancer that hasn't, not so bad. If you figure out a person has not cancer, obviously, but it has, people are dying. So it's always the problem that the machine is never right or wrong. I think the only question coming to self-driving cars, is it on average, probabilistically, more safe to drive autonomous, or is it more safe to drive with a human? Can you resolve more support tickets or more accurate support tickets with a human or with a machine? Can you hire better with humans or with a machine? Can you set a trainer that trains sales agents better, or is the machine better? And the quality is the one dimension. The second is about costs. So typically, it's in business about saving costs, and costs in self-driving cars, to conclude, is about not needing to drive because you can do different things while not driving.
Ilya?
Speaking specifically about adversarial examples, it's a valid remark. I would say it's extremely interesting phenomenon because it proves that deep neural networks as they work now work really differently from human vision system. And despite there are some similarities, it just proves that the algorithm is different. Well, it's not super surprising given that there is no backpropagation in brain probably, but that just also proves that the function is different, the inference. However, adversarial examples are important theoretically, but almost meaningless practically, because in the majority of practical situations, adversarial attack is impossible or not the best method of attack. If you want to destroy the self-driving car, you can use either method to destroy it. So I would say theoretically super important. Maybe also it will show us the right path to human level machine learning, or maybe not. But in practice, adversarial examples are not that important.
All right, thank you very much. I think there's a lot to discuss afterwards over beer, wine, and I saw many other tasty things. So, Darja, Erik, Ilya, thank you very much for being here, being so open, discussing it. Thank you for your questions, and have a lovely evening.